Alright, we don't have a lot of time, so I want to get straight into it. What you see here is some of the important properties for radicals. And I probably haven't used this term a lot, but the number underneath the radical sign is called the radicand. I've said index and root many times. Okay? And so most of these properties are going to be based on knowing the index and root and the exponent for the radicand. And so here's one. And I think I've showed you this one before, but if not, let's pay attention. This property says that this fraction as an exponent is equal to this radical here. Now remember, whenever a number has an exponent of 1, we don't really write the 1. So really there's a 1 right here as the exponent on the radicand, but we don't have to write it. So basically the denominator of the fraction is your index or root, and the numerator turns out to be the exponent underneath the radical. Now in the second property here, it's basically saying the same thing here, where the denominator is your index always, and the numerator is the exponent underneath the radical. But it expands it a little bit and says if you raise that whole thing to that exponent underneath the radical, not when it's still there, that these two are equivalent statements here. Whether you raise the whole radical to that exponent or just the underneath the radicand with the radicand, these two are saying a lot of the same things. Okay, and we'll work on that. We need to know these properties because it's going to help us understand what we're going to be doing today. You got to forgive me because I don't have a lot of energy and my voice is crusty sounding because I'm still sick. Got a headache too. Alright, so notice C here. This property says basically if the exponent in the radicand, on the radicand, is the same as your index, then the answer, or what's going to come out from a situation like this, is whatever's underneath the radical. The radicand is your answer. And here's an example of that. Notice that whenever the number is not written, it's a 2 there. And since the exponent here is a 2, then that equals just x. Here's a 5 here. And since the index is 5, the exponent is 5, the index is 5. The answer is just x. It's always just the radicand without the radical. Without the radical. A lot of people make that mistake and they'll keep the radical. Alright, and this is one we've used before, that you can separate an individual radical into two separate ones, and this is true for division as well. If they started out under the same radicand using the same index, you can separate them into multiplication, and the same thing goes for division as well. You can separate them. And so now that's important. Those properties are important, so we can get into what we really need to talk about. Alright, I want y'all to make a note of this in your notes. This line here, these lines here, okay? It's important because that's what we're going to talk about. When multiplying radicals with different indexes, okay? Change to rational exponents first. Find a common denominator in order to add the exponents. Then rewrite the radical in radical notation, okay? So this is important. So here's a hint. You can say hint or note. Alright? When multiplying radicals with different indices, change to rational exponents first. Find a common denominator in order to add the exponents. Then rewrite the radical notation as shown below. Okay. Let's take a look at this. Alright? First of all, notice I have two different indices. The index or root here is 3. The index or root here is 2. And before these notes, we haven't been able to multiply these. And so if you understood the hint said first write these as rational exponents. And a rational exponent is simply an exponent that's a fraction. And with radicals, you can do that. So if you understood what those properties were saying, I can rewrite this as x to the 2/3 power. Remember, the denominator is the index, and the numerator is the exponent for the radicand. And over here, I can do x to the 5 over 2, where the denominator is the index and the numerator is the exponent underneath the radicand. And so that's the first thing we need to make sure we're understanding, is how to take radicals and write them with rational exponents as something with a fractional exponent. I think I've told you guys in class that the square root of 9, for example, is 3, but 9 to the 1/2 is also 3. In fact, if you use your calculator and you put 36 or 49 or 100, any perfect square to the 1/2 power, it's going to show you the answer is the root, the actual square root there, because the 1/2 power is the same thing as a square root. All right. Now, in order to multiply these, remember, you multiply with the exponents by adding them. The only time you multiply exponents is if you have an exponent power raised to another power. Okay, this would be x to the a times b. But whenever you multiplying the bases, you add the exponents and so forth. In order for me to add 2/3 to 5/2, what do I have to have? Common denominators. Okay, and so I'm going to go ahead and get common denominators. Okay, so I just went ahead and skipped ahead a little bit. But basically I took 2/3 and 5/2, got common denominators here, and that became 4 over 6 and 15 over 6. Now those denominators are the same, which makes this equal 19 over 6 when you actually add them together. So what does that mean? That means when I multiply these two together, they equal actually 19 over 6. Now, I started out in radical form, and so I want to keep it in radical form as I end. So I'm not going to stop here. I want to go ahead and say that this is the same thing as 6x, the 6th root, of x to the 19th power. The numerator is the exponent underneath. The denominator is the index or the root of your radical. So you can multiply if they have different indices, but this is the process. And again, the process is change to rational exponents first, find a common denominator in order to add the exponents, then rewrite in radical notation. And that's exactly what I did in my example here. All right, let's do a couple more examples. All right, here's another example where my index is a 2 and my index is a 4. Alright, so before I do anything here, I need to first change these to rational exponents. Remember, rational exponents means fractional exponents. And I don't just make them up. The problem, this particular part tells me which fraction goes there. The index is 2, the exponent here is 1. Now see, on a problem like this, you don't see the 1 or the 2. You have to know that they exist, and so you need to make sure you write it. Times a to the 3/4. Alright, that's the exponent on the top and the index on the bottom. Numerator, denominator. Now, I need to get common denominators just for these. Why? Because whenever you multiply the base, you multiply by adding the exponents. And so I have 1/2 plus 3/4. And in order to get common denominators, I just simply need to multiply this by a factor of 1, which in this case is 2 over 2. Any number divided by itself is 1. So you get 2 over 4 plus 3 over 4, and that equals 5 over 4. So what is that? Is 5 over 4 my answer? No. That means a is now a to the 5/4 power. Whenever you add those two after getting common denominators, you get 5 over 4. Alright? Now once you get 5/4, what you have to do now is remember how to write that in radical form. And so this now becomes the 4th root of a to the 5th power. And we need to be able to say that. We need to be able to express these terms properly. The statement says the 4th root of a to the 5th power. Alright, let's try more. Actually, before we try more, I just thought about this. This is not simplified. You should always leave your answers in simplified form. And the fourth root of a to the fifth, that actually equals a fourth root of a. Now, just in case you forgot or don't understand why this is really the answer and not this, I'm going to do upside down division. If I write 5 a's, that's how many I have. The index tells me how many of one it takes of one number or letter for one of them to come out. And it takes 4. So here's 4 a's. So 1 a can come out. So that's the a that came out. And that leaves an a underneath. And so a fourth root of a is really the answer to that last example. Always look to simplify. And I'm glad I caught myself. I'm blaming it on my cold. But always look to simplify if you can. Alright? Don't forget that. That's the answer to that particular example there. And of course, that means I need to go back to this first example. Alright? So, I'm cool with everything I did here. But, as my brain kicked in, I realized I haven't simplified this one either. I could write out 19 x's here, but I'm not going to do that. Okay? How many times does 6 go into 19 evenly? Okay? Hopefully, you know that that's 3. So, 3 x's ought to be able to come out. Alright? And so, that leaves me 6 root of x to the first power. Okay, what I'd like to do is show you these examples here with the time I have left. I'll try to go as fast as I can. But notice I have fractional exponents. Now this is based on some of the old stuff that we've talked about in the past. But a power to a power means you multiply, and 4 times 1/2 is 2. So this is the same thing as n squared. Now, just in case you wonder how this relates to what we're doing, this really means the square root of n to the 4th. Shouldn't that be n squared? Yes, it should. This right here really means the square root of 64m to the 4th all cubed. This is the exponent down here, and this is the index. Alright? Okay, for the sake of time, I went ahead and finished the problem. If you raise everything under here to the 3rd power, you get something like this. But I just wanted to show you real quick that you can actually put 64 to the, can't hardly see it. That sucks. There you go. 64 to the 3/2 in your calculator, and it'll tell you. Your calculator know how to do fractional exponents. And so all I did was raise everything to the 3rd power, to 64 m to the 4th, and then you take the square root, and you'll get 5, 12, and m to the 6th. Alright? Okay, still using those same properties about radicals. I want to be able to write this in exponential form. I got some radicals that I want to write as exponents. So, the index here is 2, right? So this would be 10 to the 3/2. That's how we use that. Exponential form. These two are equivalent statements. And this one would be 2 to the 5/4. Same thing. Numerator and index is denominator. Alright, now I need to write these in radical form, not just exponents. They're already in exponential form. Now I need to write them as radicals. And so that's the square root of 6v to the 3rd power. How do I know that that's the square root? Because the denominator is your index. It always like that. The numerator is your exponent on the outside. And finally here, I would have the square root of 36 to the 3rd power. Or you could say square root of 36 cubed. Same thing. means the same exact thing.